Have you ever just stopped and wondered about the magic that makes a fan spin, or a blender roar to life, or even how an electric car just glides by without a sound? It really does feel like magic, right? But it's not. It's the electric motor. And in this explainer, we're going to pull back the curtain and see exactly how this incredible trick works. All right, let's get into it.
It really all comes down to this one simple question. I mean, think about it. We are surrounded, absolutely surrounded by things that move on their own, with no one pushing them. The secret to all of it is a brilliant little device that turns invisible power into very visible motion.
So, here's how we're going to break it all down. First, we'll talk about the everyday magic of the motor. Then, we'll uncover the secret ingredients that make it spin. After that, we'll get into the push and flip dance. Then, we'll check out AC motors, the whirlpool effect, and the absolute kings of motors inside EVs. And finally, we'll tie it all together and see why this stuff really matters.
Okay, first up, everyday magic. And, I really mean that. Once you start actually looking for them, you realize electric motors are the quiet, hidden workhorses of our entire modern world. Just think about your day so far. Did you, feel a breeze from a fan? Use an electric toothbrush? Maybe hear that little hum from your computer's cooling fan? Well, all of those things, from the tiniest toy drone to the massive powertrain in an EV, they're all powered by an electric motor. They are, quite literally, everywhere. So how on earth do they do it? It's not nearly as complicated as you might think. It really just comes down to three basic ingredients that, when you put them together, create motion. So let's meet our key players.
First up, we've got electricity. Honestly, the best way to picture this is like a flow of tiny, invisible ants, or, electrons, just marching single file through a wire. And just like a long line of real ants can move a leaf, this flow of electrons has the power to push things around. Our second ingredient is the magnet, and we've all played with these, right? They've got a north and a south pole, and they create this incredible invisible force field that can push or pull other things. The rule is super simple. Opposites attract, and similar poles push each other away. This whole force without touching thing, it's absolutely crucial. And now for our final and maybe most clever ingredient, the coil. It's really just a wire that's been wrapped into a loop, but here is the real magic trick. When you send our invisible ants, that electricity, flowing through this coil, it instantly turns into a magnet, a temporary one called an electromagnet. This right here is the core secret to the whole shebang.
So here it is. The big secret is this simple formula. You take the flow of electricity, combine it with the push and pull of magnets by using a coil to turn that electricity into a magnet, and what do you get? You get motion. This is the fundamental recipe for every single electric motor out there. Now, let's see how these ingredients actually work together in what I like to call the push and flip dance. We're going to look at a simple DC motor, the kind you'd find in a little battery-powered toy.
Okay, so it all happens in 5 basic steps. 1, power on. Electricity flows into the coil and boom, it's an electromagnet. 2, that new magnet gets pushed or pulled by a permanent magnet sitting right next to it. 3, that push forces the coil to spin, but only about halfway. And right here, this is the genius part. Step 4, a tiny switch inside the motor. It's called a commutator. It flips the direction of the electricity. This reverses the coil's magnetic poles. So in step 5, it gets another push in the same direction, creating this continuous spin. It's just push, flip, over and over again.
And this shows you exactly why that flip is so important. Without it, the coil would just get pushed once and then it would get stuck. It would just sit there. But that commutator, it acts like a clever little brain, reversing the polarity at the perfect instant, so the push never ever stops. It's what ensures the spin just keeps on going. Okay, so let's move on to AC motors. These are the ones powering things like your ceiling fan and other appliances. Now, these are a bit different because the electricity they use, alternating current, is already flipping its direction all by itself. So they use a different kind of trick. So instead of a physical switch, AC motors create something called a rotating magnetic field. Just picture a few electromagnets set up in a circle. They switch on and off in a perfect sequence. 1, 2, 3. 1, 2, 3. And this creates a magnetic field that spins around like a whirlpool. The spinning part in the middle, called the rotor, it just gets caught in this whirlpool and gets dragged along for the ride.
Yeah, this quote pretty much nails it. It really is a magnetic merry-go-round. The magnets on the outside are creating this moving target,
and the rotor on the inside is just constantly playing catch-up, chasing that moving magnetic field. And that chase is what gives you the smooth, constant spin of your fan. So just how fast can these things get? Well, check this out. The motors in those high-speed blenders, which are called universal motors, can hit an insane 20,000 revolutions per minute. That's 20,000 full spins every single 60 seconds. That incredible speed is what gives them the raw power to just pulverize anything you drop in there.
And all of this leads us right to the top of the mountain, the absolute pinnacle of motor technology, the crazy powerful and efficient motors that act as the heart of every single electric vehicle. These truly are the kings of the motor world.
So there are a few main types, but they all build on the same ideas we've been talking about. You've got brushless DC or BLDC motors. Think of them like super smart DC motors that use electronics instead of a physical switch for perfect timing. Then there are induction motors, the kind Tesla made famous, which get the rotor to chase a rotating field, kind of like a dog chasing a laser pointer. And then you have permanent magnet motors, which use really powerful magnets on the rotor that follow the spinning field with incredible precision, giving them amazing efficiency and power.
So, what's the big takeaway here? Why does any of this matter? Well, it's because at its very core, an electric motor is just a beautiful, elegant example of energy conversion.
So here's the journey. You start with electrical energy, right? From a battery or the wall. The motor takes that and transforms it into magnetic energy, that invisible force field we talked about. And finally, that magnetic field is used to create a pushing force, which becomes mechanical motion, the spinning that actually does all the work. It's a perfect three-step transformation from electricity to movement.
And what's just so amazing is that this exact same principle, this same idea, it scales up and down to power pretty much everything that moves in our world. From the tiny little spark that spins a toy car's wheels to the incredible force needed to lift an elevator or give an EV that breathtaking acceleration, it is all the same fundamental dance between electricity and magnetism.
So if you remember just one thing from all of this, let it be this simple idea. At the very heart of all this everyday magic, from your toothbrush to a Tesla, is one simple, powerful, and totally elegant concept. Magnetic push creates motion.